These strange features in Syria Planum are still being widely debated. They have the same general form as transverse Aeolian ridges called tars elsewhere on Mars, which are wind-blown deposits that are common in the Martian tropics. Their height and spacing are similar to the more familiar-looking tars in other places, and they are similarly bright. Unless nature is perverse, they were both made by the same process. Yet the tars here in Syria Planum appear different than typical tars elsewhere on the planet. They have blunt edges in contrast to the tapering ends of typical tars. The ridge crests are serrated, unlike the smooth crests of most tars. They are layered on their upwind faces and scoured on the downwind sides, whereas tars are usually smooth and symmetric. It's still a mystery why these tars are so bizarre. Scientists have discovered evidence that could help answer questions surrounding the history of water loss on Mars. A new research which comes after a decade of exploration by NASA's MAVEN, short for Mars Atmospheric Volatile Evolution Mission, shows evidence of an escape process known as sputtering, during which atoms and molecules are knocked out of the atmosphere by what are known as charged particles as they crash into the atmosphere really fast. Scientists have abundance of evidence that water existed on the Martian surface billions of years ago. but they have been trying to find out where it went. Research has shown that when Mars lost its magnetic field, its surface was exposed to solar wind storms that allowed the liquid water to escape into space. But that does not explain why the once thick Martian atmosphere was almost entirely stripped away. Sputtering the newfound evidence could help explain that. Scientists used a series of MAVEN tools to measure several atmospheric factors in both daylight and dark at low altitudes to observe the phenomenon, which took years to complete. The combination of data from these instruments allowed scientists to make a new kind of map of sputtered argon in relation to the solar wind. This map revealed the presence of argon at high altitudes in exact locations that the energetic particles crashed into the atmosphere and splashed out argon, showing sputtering in real time. Researchers have determined at least one of the causes for the loss of water on the Martian surface, but they were also able to recreate the conditions that may have made the planet inhabitable billions of years ago. The workings of the Martian winds are visible in this image of sand dunes trapped inside an unnamed crater in southern Terra Chimeria. Many of the craters in the southern highlands of Mars contain sand dunes, and HiRISE is still in the process of mapping these dunes and determining how active they are today. So far, the dunes in these craters appear to be a mixed bunch, with some dunes actively advancing while others seem to be frozen in place. The sand dunes are the large branched ridges and dark patches that are conspicuous against the bright background, particularly in the northwest corner of this picture. There are also signs of two other wind-related processes. Smaller braided ridges line the floor of the crater in regularly spaced rows. These are also wind-blown deposits, mysterious transverse aeolian ridges or tars that are more common in the Martian tropics. Faint, irregular dark lines cross the dunes and the tars, marking the tracks of dust devils that vacuum the surface during southern summer. It is not sure which one of these features came first, but we can untangle the history of these processes by looking at the picture more closely. Over most of the image, it is obvious that the dark sand dunes bury the bright tars, meaning that the sand dunes are younger than the tars. But this relationship is not so clear for the southernmost dune, where the tars look like they extend into the dune and merge with ripples on the dune's surface, suggesting that the tars might be younger than the dunes. The question can be resolved by carefully examining an enhanced color cutout of the image. In the image, the tars are brighter and redder than the sand dunes, and this color persists on the crests of the tars as the sand encroaches, burying the valleys first and then the slopes and finally the tar crests. This tells us that the unusual appearance of the dune margin is caused by burial and exposure of the older tars by the younger sand. Finally, you can trace the tracks of dust devils crossing over the dunes, telling us that they are younger than the dunes. So first came the tars, next the dunes, and last the dust devils.